Hello students, and welcome back to another algebra video. You know what to do. Pause the video, try this problem in your notes, and then unpause it, and let's do it together. Graph the system of linear inequalities. Step number 1 is to graph each linear inequality. So we'll do the first one in red. I have a y-intercept of -3 and a slope of 2, which I can think of as 2 over 1. So I'll rise 2 and run 1. And let's see, that is just greater than, so this will be a dotted line. Perfect. Okay. Now, should I shade up here or over here? Which half plane should I shade? Let's plug in 0, 0 and see whether or not it is a solution. So I have 0 is greater than 2 times 0 minus 3, which means 0 is greater than 0 minus 3. 0 is greater than -3. Is that true? Is 0 greater than -3? No. 0 is not. Oh, wait a minute. Wait a minute, yes. Haha, I was thinking of 3. Yes, 0 is bigger than -3 because 0 is greater than any negative number. So, because it is a solution, we will shade the side, the half plane that contains 0, 0. So everything over here gets colored in. Wonderful. Let's do equation number 2 in purple, because purple's my favorite color. So I have a y-intercept of 1 and a slope of 1/2. So I am going to rise 1 and run 2. And this will be a solid line because I have it greater than or equal to, this will be a solid line. So, where should I shade? Should I shade on the bottom or on the top? Let's plug in 0, 0. 0 is greater than 1/2 times 0 plus 1. 0 is greater than 0 plus 1. 0 is greater than 1. Is that true? No, that is not true. So, I am going to shade the half plane that does not contain 0, 0. I'm going to shade above the purple line. All right, now, where is the overlap? Well, let's see. Everything above the purple line is good, and everything to the left of the red line is good. So, here is the intersection. Here is where the black section here, the black region, is where the lines, or excuse me, where the half planes intersect. So, this is the graph of our system of linear inequalities. Woohoo! Wonderful. All right, let's move on to our learning target and success criteria for today. We're finishing section 5.7 and actually finishing chapter 5 today with a learning target of, I know what systems of linear inequalities look like on a graph. Now, you may already know this, that's okay, but we're aiming to solidify our learning about what do systems of linear inequalities look like on a graph. Okay, and our success criteria is that you can write a system of linear inequalities from a graph. So now you understand why our learning target is so important. In order to be able to write a system of linear inequalities, you need to know what they look like on a graph. If it looks like this, this is what the system will be. If it looks like that, this is how the system will be different. And so on and so forth. So, in the last video, I gave you a system of linear inequalities. Like in the entry task, I gave you a system of linear inequalities, you give me a graph. Today, in this video, I'm going to give you the graph. You need to write me the system of linear inequalities. Ho-ho! So we're doing the reverse of what we did yesterday. All right, so in order to talk more about systems of linear inequalities, let's make sure that we remember what they are. A set of two or more linear inequalities in the same variables. So, we have two inequalities, both have x and y in them. Yep. Now, we're going to jump right in to example 4. Write a system of linear inequalities represented by the graph. So, here's what we know. We know I have two lines, so let's make one of them red so that I can call this the red inequality and I can call this the blue inequality. Now, if this is the shaded region, that must mean that the solutions to the red inequality were everything above the line. If it were down here, if it were this half plane, then this couldn't be shaded. So the solution to the red half plane must be everything above of this red line. Now, what is this red line? It's a horizontal line that goes through -2. So the boundary line is y equals -2, because y makes the horizontal lines. And now if I want a linear inequality, what should this equal sign be? Should it be greater than, less than, greater than, or equal to? Well, if I'm shading above the line -2, I'm shading everything that is greater. So I have y is greater than. Now, notice that the line is solid. So that means that I am greater than or equal to. And there you go. That is inequality number 1 of our system. Now, all we need is inequality number 2. So I'm going to erase the graph. If you haven't finished writing this in your own notes, pause the video and make sure to finish that. But we are going to look at the blue dotted line now. We're going to look at this dotted line here. I kind of made it look solid, so I'm not going to... We're looking at this line now. And where does it need to be shaded in order for this to be the solution? Well, if I shaded the top half plane, I couldn't have this as my solution because it wouldn't overlap here. So the solution must have been this bottom right half plane here. Okay. Now, what's the boundary line? What's the boundary line? I have y equals what? mx plus b. But what is b? Let's see, the y-intercept is 0. b is 0. So I have mx plus 0. So I don't even need to write the plus 0. I'm just going to have y equals mx. Now, what is the slope? Well, I notice that if I start at the y-intercept, I go up 1 over 1. So I rise 1 and run 1. Oh, so my slope is 1. Oh. So this is the line y equals x. 1x, but remember I don't need the 1 in front of it. Y equals x. Okay. Now remember, that's the boundary line, but I want the inequality. So what symbol should go here? Y is greater than x? Less than x? Well, we could test a point and see, or we could think I am shading below this line. right? I'm not shading on top of the line, I'm shading below the line. So that would mean that we want x to be less than, or excuse me, we want y to be less than. I want to shade below the line. Okay, and it's a dotted line. It is a dotted line, which means that I'm just less than. Not less than or equal to, just less than. Aha! Fantastic. So this is our final answer. We think that this is our system of linear inequalities. Let's check and make sure that we were correct. So, the horizontal boundary line passes through 0, -2, so an equation of the line is 0, -2. The shaded region is above, so the line is y is greater than -2. Hey, that's what we had. And inequality number 2, the slope is 1, and the y-intercept is 0. So a boundary line equation is y equals x. Shaded region is below the dashed boundary line, so the inequality is y is less than x. This is exactly what we had. So, we were correct. Woohoo! All right, we have another example. It's the same as example number 4, but it's a different problem. Same thing, different problem. So, at this point, I would like you to pause the video and try this example in your own notes. Try it on your own and see if you can write a system of linear inequalities for this graph. Then, remember, if you get stuck, if you can't finish it, that's okay. But I want you to try on your own, because the more that we try, the more we struggle, the more we make mistakes, the more our brain grows. That's part of learning, and that's normal, and that's okay. So try it on your own. If you get stuck, you can do it with me. All right, I'm going to take this solid line, and I'm going to change it to be red. So we can have this be our red inequality. Now, it crosses the x-axis at 3, so x equals 3 would be an equation of this vertical line. Remember, vertical lines have x equals. Okay, now, have I shaded to the left or have I shaded to the right? Well, in order for this shaded region to be our solution set, I must have shaded on the left. So, how does that change my inequality sign? Is it less than? Is it greater than? What do we think? Well, if x is equal to 3 at this line, I'm shading numbers like 2, numbers like 0, and those numbers are less than 3. So, because we're on the left, we are less than 3. And notice this is a solid, solid, I can't spell today. It's a solid line, so we are less than or equal to. Okay, I'm going to erase the red so that we can see enough for the blue inequality. So, if you need to pause the video and finish taking these notes, do it. I'm going to erase it so that we can look at this dashed blue line here. Okay, so, first thing, I know that the boundary line, because it's not a horizontal or vertical line, it's like a diagonal, it's like a slanted line, so I know that it's going to be of the form y equals mx plus b. What is the y-intercept? -1. -1. And what is the slope? Let's see, I go, where is another point? Let's see, here. This is another point where it crosses, so I'm going up 2, so I rise 2, and I run 1, 2, 3. So my slope is 2/3. And there is my boundary line. y equals 2/3 x minus 1. Now, where is the shading for this blue line, for this boundary line? Is it below? Is it above? Which half plane should be shaded? Well, if our solution set is over here, of course, we have to be above this line, because that's where the solutions are. So, if I am shading above the line, that means that y must be greater than 2/3 x minus 1. And because this is a dotted line, that means that I just have greater than. No greater than or equal to, none of that, just greater than. Okay, let's check and make sure that we were correct. So, the vertical boundary line passes through 3, 0, so an equation is x equals 3. Shaded line is to the left of the solid boundary line, so we have x is less than 3. Haha, perfect. The slope of the other boundary line is 2/3. The y-intercept is -1, so an equation is 2/3 x minus 1. And the shaded region is above the dashed or dotted boundary line, so an inequality is y is greater than 2/3 x minus 1. Yay! And look at that. This is exactly what we had. So we are correct. Okay, at this time, it is time for you to think. If you have any questions, if you are confused about anything in this video, because if you have your questions, we need to get you some answers. If you have questions, it means that you might have some holes in your learning, some holes in your understanding of the learning target or the success criteria, and the answer could be that missing puzzle piece that will fill in the hole that is your lack of understanding. So, rate yourself now on a scale of 1 to 3, where 1 is I need help, I'm confused, and 2 is okay, kinda, a little bit, I'm getting there, I think I got it, and 3 is yes, I am so confident, I know, I understand. So, take the appropriate action based on where you think your understanding of the learning target and the success criteria is. Do you understand how the graph of a system of linear inequalities works? Can you write a system of linear inequalities given a graph? And take the appropriate action, so ask questions, try the homework, help a friend, whatever it is that you need to do. But get your questions answered. Put that puzzle piece in the hole of your understanding. Here are some practice problems that you can do to practice the skills that you have learned in this video. Both of them are like examples 4 and 5, or excuse me, all of them are like examples 4 and 5 because both examples 4 and 5 were the same thing. And let's end with a launch, shall we? Today's launch comes from Eleanor Roosevelt, and they say, "The future belongs to those who believe in the beauty of their dreams." Maybe you've heard of this saying before, maybe you haven't, but the future belongs to those who believe in the beauty of their dreams. The future belongs to them. What does that mean for the future to belong to you? If something belongs to me, it is mine. I am in control of it. So if the future belongs to you, it means you're in charge of your future. You are in control of your future, and you get to make it what you want it to be. So how do we get there? How do we have the future belong to us? Well, it belongs to those who believe in the beauty of their dreams. If you want your future to look a certain way, you need to believe in yourself. And that sounds really cliche and like you just gotta believe. But your attitude is everything. If you believe something in your heart and soul to be true, you'll act like it. And if you believe in your heart and soul that something isn't true, or you don't fully believe that something is true, you're going to act on that as well. If I believe that I can work out every day and I can see results, and that if I stick to it, if I stick to working out every day, I will see results, I believe that, I'm probably going to be more willing to work out. But if I don't believe that it's going to pay off, if I don't believe that I'll see results, why would I run, right? My subconscious says, oh, you might not see results. You probably won't see results. Even if you run, nothing's gonna happen. Nothing changes when you try to run. Why would I run? And it's easy to beat yourself up for thinking that way, but you need to understand where those thoughts are coming from. Why do you think it's not going to make a difference if you run? So understand, like, what is keeping you from believing in yourself? Because if you believe in yourself, if you believe in your dreams, the future belongs to you. So that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.